On the first day of training, you learned about MX and Spark components, including the Spark containers like application, panel, and group. These containers are used to lay out and display other containers and visual controls. In this video, you will learn about the data group container, which also displays content but based on a defined set of data. You will also learn how to use two default Spark item renderers for the data group container that define a uniform repeatable display for each record in the dataset. You will first learn how to display string data in an item renderer, and then you will learn how to pass visual UI components in the dataset. Lastly, you will create an item renderer that can perform a conditional check to dynamically determine the appropriate item renderer to display both types of data. This is a conceptual diagram of an item renderer for a data group container. Here is the data group container on the right, and here is the dataset on the left. The job of the data group container is to iterate over all the data items in the data set, or in Flex terms, the data provider, and generate a visual display in the data group container for each item. The data for each item is laid out in a specific configuration based on the directions in the layout template, or again in Flex terms, the item renderer. In this video, you will use two default item renderers that are available in the Spark package. In the next video, you will learn how to create your own custom item renderer. Let's begin with an overview of the data group container basics. First, the data group container is a Spark component. It accepts the dataset for display through a data provider property. In this property, you can define simple strings and numbers, or complex data such as object and XML instances. The data group class converts these data elements into visual elements for display using an item renderer. Keep in mind that the data group container is a non-skinnable container. I will address the last point in day 5 of this training. This is the starter MXML application file for this video and related exercise. I will first show you how to work with simple text data. The data itself is a non-visual element, so I am creating it in the declarations tag block. Within this tag block, I am creating an array list instance with an ID value of employee list. I am pasting 6 string instances with employee names. This is my data set. Below the label control, I am creating a data group container block and adding a data provider property. To this property, I am binding the employee list instance of data that I just created. You may be wondering why I chose to create an array list instance instead of an array collection instance. In previous videos and exercises, we have worked almost exclusively with the array collection class, because when you are working with array data, you will often want to manipulate and sort that data using the methods provided in the array collection class. The array list class doesn't have most of these data manipulation methods, which makes it a lighter weight instance to create. In this case, I'm simply going to bind some static data to the data group control for display, and the array list class will fit that need better than the array collection class. When I save the file and run the application, you can see a runtime error that says that the Flash player could not create the item renderer for Andrew Brilliam. The data group container requires that you also define an item renderer property that references an item renderer class instance. An item renderer class defines how the provided data will be visualized and is based on the type of data that will be displayed. There are two default item renderer classes that are in the spark.skins.spark package. The default item renderer class is used to display simple data like strings or numbers. The default complex item renderer is used to display UI components. As I mentioned earlier, you will learn how to create a custom item renderer in the next video. Also remember that the data group component is a container with a layout property. By default, all of its content is laid out using the basic layout class, but you can change this, as you will see shortly. Back in Flash Builder, I'm adding an item renderer property to the data group container instance and setting its value to spark.skins.spark.defaultItemRenderer. When I save the file and run the application, you see only a black blob. Remember that I said the default layout property value is the basic layout class. This means that all the data elements have x and y values of 0 and are stacked on top of each other in the display. Inside the data group container tag set, I am creating a layout property tag set and assigning a vertical layout instance for its value. When I save the file and run the application, you can see that the employee names are displayed vertically below the header text. Earlier, I mentioned that you would use the default complex item renderer class to display visual components. This literally means that you assign the UI elements as the data in your data provider property. In this code example, the array list instance has image MX controls rather than string values for the data. In the array list instance, I have added 6 MX image controls below the string values. The source property for each instance points to a JPEG in this images directory. In the data group container instance, I now need to update the item renderer to use the default complex item renderer class. When I save the file and run the application, you see only the employee images and not their names displayed, despite the fact that the name strings are in the data provider. This happens because the default complex item renderer only displays visual elements and does not display simple text values. To mix the two types of data, I will implement the item renderer function property, which will evaluate the type of data to be displayed and then use the proper item renderer class for the job. You will pass each data item to the function as an object instance, and the function will use a class name classFactory to create a new instance of the appropriate renderer and return it to the data group container. The function itself determines the type of data in the item by doing a simple data type check. If the data is simple, you will create a default item renderer instance. If the data is a visual element, then you will instantiate the default complex item renderer class. In the data group component instance, I am removing the item renderer property and adding the item renderer function property with a value of renderer function. My next step is to create this function to test each data element defined in the array list instance to determine the correct item renderer to use. Below the script comment, I am creating a script block and using the import statement to import the spark.skins.spark.defaultItemRenderer class and to import the spark.skins.spark.defaultComplexItemRenderer class. Next, I'm creating a private function named renderFunction, as I referenced here in the data group tag. The function takes one argument, which I am naming item, and data typing to a generic object. Remember that each data element in the array list instance will be passed to this function. That means that the item argument will represent one of these strings or image instances. The return type for this function is the classFactory class. Within the renderer function, I'm creating an if statement that evaluates if the item parameter value is a string instance. If true, I am using the return keyword and then the new keyword to call the class factory class constructor. Remember that the class factory class creates an instance of a class. In this case, since the data type is a string, I'm creating an instance of the default item renderer class. Now I'm creating an else statement and returning a new instance, again using the class factory class, of the default complex item renderer class. When I save the file and run the application, you can see that the string and image data are displayed, but the string values are not displayed above the correct images. In the ArrayList instance, I am rearranging the data objects so that the image controls follow their respective string values. When I save the file and run the application again, you now see that the image and string values are properly displayed. For your next step, work through the exercise titled Passing Data to Item Renderers for Display.